Hello, my name is Keshwani. It's Keshwani, Keshwani. I have been solving data sufficiency problems out of this book here, GMAT Review, the official guide, the 12th edition. If you do not own this book already, purchase one immediately. You should be able to find it at mba.com. mba.com is the same official website where you would go to register to take the exam. The problem that I'm about to solve is the one that you're going to find on page number 274, data sufficiency problem, hence the DS, number 18. Number 18, let's take a look at it. It says, what is the maximum number of rectangular blocks, each with a dimension of 12 centimeter, I don't have to write the centimeter, the unit is of no significance here, each with the 12 by 6 by 4, whatever the units happens to be. Here the units are centimeters. The question is, how many of these, what's the maximum number of these rectangular boxes that will fit inside a rectangular box X? So apparently we have a huge rectangular box which they're calling X, and inside that huge box the question is, how many of these tiny rectangular boxes I can fit in? That's the question. Let's see what they give us in the first statement. Again, this is a data sufficiency problem. As soon as the data sufficiency problem pops up on the screen, always get in the habit of writing down A, D, B, C, E. A, D, B, C, E. Because the answer choice has to be either this group or that group. Let's see what the first statement says. It says when box X, remember box X is the large box that in which we are asked to find out what's the largest number of small rectangular boxes that we can put in. When the box X is filled with blocks and rest on a certain side, they don't tell you which side, maybe it's resting on whatever the side it is resting on, because we don't have the dimensions for it. I was just for a second I forgot, these dimensions are the dimensions of the small rectangular box. We have no knowledge as to what the dimensions are of the larger box. But anyway, if it's resting on one of the side, and they tell us that when that happens, there are 25 blocks in the bottom layers. There are 25 blocks in the bottom layers. Well, does that help us in figuring it out, in figuring out what is the maximum number of small blocks that will fit in the larger box? The answer is no, because they tell you, I'm going to read one more time. There are 25 blocks in the bottom layers. Great, fine and dandy, 25 blocks in the bottom layers. But how many layers are there? If you tell me how many layers there are there, of course we can figure out the number of small rectangular boxes that will fit in the large box. But of course they're not going to tell you how many layers there are, because that will make it too simple. The bottom line here is that just knowing that there are 25 of the small rectangular boxes in the large box. Here's my large box. Let me see if I can draw it here. I'm going to erase this thing and I'm going to put this on the bottom here so that you can see the picture properly. This looks almost like a cube, doesn't it? I didn't mean to draw a cube. It's not a cube. They tell you specifically that it's a box. A rectangular box is what is known as something that is where the all sides are not equal. So let's draw a rectangular box. There you go. There is your rectangular box, and in the bottom 25 of the small boxes are sitting. Now bottom doesn't necessarily mean that this is the bottom layer. They don't tell you which side is resting on. Maybe it's resting on this side, maybe it's resting on that side, or who knows. There are 3 different ways you can put your box. Here's my rectangular box. It may be resting like this, it may be resting like this, or it may be resting like this. Who knows? But anyway, the bottom line is that just because you tell me there are 25 of them in the bottom layer, that does not help me in answering how many what's the maximum I can fit in there, the large box, because I don't know how many layers there are. The statement 1 by itself is not enough. statement 1 by itself is not enough. A, D, B, C, E. Since we just established the statement 1 by itself is not enough, the answer cannot be A. And therefore, the answer also cannot be D. Answer would have to be one of these three. Let's look at second statement. Perhaps second statement would be something more helpful, easier to deal with. The inside dimensions of the box are 60 by 30 by 20. There you go, that helps. 60 by 30 by 20. Well, that would help a great deal. Now we can figure out how many of the small boxes we can fit in. We can fit in the large box with just by statement number 2. The statement number 2 tells me that the dimensions are 60 by 30 by 20 of the large box. That is enough information by itself in figuring it out how many small rectangular boxes will fit in the large box, because here are the dimensions. There seems to be an extraordinarily high level of gravitational pull today, because all the markers are falling down. Here are the dimensions of the small box. So 60, that we can put it in here, and 6 will go right in here, because they're very nice. They give you an order. See? So basically, it looks like 60 divided by 12, that's a 5. 30 divided by 6, that's a 5. And 20 divided by 4, that's a 5. Oh, what do you know? Well, it looks like we're going to have 5 layers. 5 layers, and each layer will have 5 by 5. And how do I know that each layer would have 5 by 5? Because that's what we heard in the first statement, even though we're not supposed to mix the information together, which is not what I'm doing here. But just the fact that we knew from the first statement that there were 25 in the first layer. The second statement by itself does answer how many will fit in. The answer is 125 of them will fit in the large box. But it also tells us there must be 5 layers, which is what the first statement did not tell us. First statement told us that there were 25 in the first layer, but we did not know how many layers there are. Well, now we know. As you can see, 25 in the first layer, and there must be 5 layers. And that's all it is. That's all it is. So the box must look like, I'm going to have to pick up the box and tilt it. We need a 5 by 5, 20. Anyway, so that's what's going on here. The dimensions are 6 by 12. So if I put a 60 here, 5 of them will fit in here. And then if I put a 30 here, 5 of them will fit in here, because you see 6 by 12. So there you go, that's your 5 by 5 right there. And there must be... I'm making too much fuss about nothing at all. 1, 2, 3, 4 and 5. 1, 2, 3, 4 and 5. There you go, voila. So that's one layer that you can see on the top, and there are 4 more layers underneath. And that's all it is. The answer was B. B tells us B is enough information to figure out, in figuring it out, how many will fit in the large box. The answer is 125. Now, point here is not that the answer is 125. That's just, it was too simple, so we figured it out. We didn't have to figure that part out. Just realizing that if you give me the dimension of the large box, of course, and you give me the dimension of the small box, I should be able to figure out how many of small will fit in the large one. Simple as that. I didn't actually have to do the figuring. We didn't actually have to do the figuring out part. I just did it because it was too simple, so I couldn't resist it. Anyway, that was it. I hope you found it helpful. If you wish to get hold of me, I do personal private tutoring, face-to-face tutoring. I also tutor over the internet through Skype, and I also do tutoring sessions over the telephone. If you wish to get hold of me for any kind of help that you might need in your preparation for GMAT, go to my website at www.for gmat.com and send me an email, alright? Or you can go to www.keshwaniprep.com and send me an email, okay? Alright, thank you.